So welcome everybody to this panel session on the openness and programmability in the RAN. My name is Marcin Dryjanski and I'm the CEO and co-founder at Rimedo Labs, a spin-off from Poznan University of Technology, the Institute of Radio Communications. And we are a research and consulting company focusing on wireless, Open RAN, 5G and beyond. And Rimedo Labs is producing XApps and RApps for RAN intelligent controller in the current Open RAN market. So on behalf of myself, the company and the organizers, I would like to welcome you to this panel session. So again, the session is entitled Openness and Programmability in the RAN. That will mostly focus on Open RAN, of course. And in this session, we will touch upon several issues or aspects like energy saving, security, standardization, current research agenda, XApps, RApps, and digital twin AI. So the total session duration will be 155 minutes. We will start with a little bit of the overview and background of the topic that I will present. And then we'll have 6 distinguished guests that each of them will present their general take on the topic, and then we will have a discussion with several questions. Then finally, we will have the floor open to the questions to all the to the audience. So let me start with this one, if it helps. Okay. So let's start with agenda. This is the picture that I'm showing for 7 years now. I did it with my colleague back when I was working at Huawei R&D office on the heterogeneous networks. Mostly the thing that we wanted to point out, and that it's still true, is that we get more and more complex networks, more frequency bands, more technologies, more features like dual connectivity. We add licensed spectrum, unlicensed spectrum, shared spectrum, 5G, NR, TDD bands, FDD bands, and so on. And we need to capture and manage those to work efficiently. That is even more important nowadays with regards to all energy-saving features. So to address this and to make sure that we can do that per use cases, because the important point here is that not all of those features fit into all the use cases. With the help, I think the Open RAN comes mostly with the intelligence. With the programmability, we have the main 4 topics related to what Open RAN is. So this aggregation of the base station into multiple building blocks, the open interfaces, but the true open interfaces, the coupling hardware from software, which is sort of a vRAN, and then for me personally, the most important one, which is intelligent management, which is brought by the RAN intelligent controller, that enables basically to add new functionalities on specifically per use case basis when we have more and more features coming into play. Now, this doesn't come without a price. And then speaking about all the advantages on Open RAN, we will in this panel also address the challenges that are currently seen in the market. So the advantages are that we basically, by decoupling and then splitting the hardware from software and the software blocks of the base station for multiple different entities, we are getting into getting more players into the system, into the ecosystem, reduce capex, quick time to market by the new functionality that are provided as software pieces, design flexibility, so how you can deploy those networks and implement those. But the challenges that come is the technology maturity at this stage, the interoperability integration, the automation of the process of, for example, bringing those XApps to the market, to the different operators, to the different use cases, security due to those new elements, the price. The question is where the price lies. If we basically have cheaper elements, but then we need to integrate, the question is if the integration cost will not be higher than the individual building blocks bringing together. And inertia from what we want to see, what we have in the research, what we have in the standardization towards the actual market deployment. On the other end, we are approaching the 6G era, where there is a lot of players already working with 6G entities, as we also heard today in the morning sessions. Both companies, research institutions, but also consortia and universities. And what is important and interesting in those is that there are two aspects that we are going to address in this panel, which is in some places or in multiple places, but with regards to 6G, we can see the AI native design and AI as part of the RAN, as well as OpenRAN, and what is, if it will manage to get into 6G in a slightly different manner that it's currently being introduced, and I will also speak about those in this panel. And then finally, how we bring these two together, the ORAN Alliance, who will be represented here by Alex Choi, and he can speak more about this, is that 6G is also present in OpenRAN standardization entity, as last year there was this new focus group focusing on research. So it's still OpenRAN brings also, or ORAN Alliance brings also universities and research institutions into the market, where the aim is that the next generation research group will focus on research and open and intelligent RAN principles for 6G. So one of the questions we will have today to answer by all of the panelists, I would say that will be the question that I would like to hear from all of them, is if OpenRAN will be part of 6G, not like it is now with 5G, that it's sort of added on after the 5G has been standardized. So the final point from my side is the challenges and lessons learned that we learned as Rimedo Labs by taking part in the ORAN Alliance activities, and also working with various vendors and providers here, developing the XApps and porting them in multiple places. So I think we had this one item that I would like to address. The second point, what was started, that we have different use cases, that we could deliver the XApps for different use cases. And that was addressed yesterday by one of the speakers, that currently within the RIC, we have, well, 1-2 XApps. And from our perspective, when we, for example, took part in the VMware Hackathon at this Mobile World Congress, is that each of them has their own instance of RIC developed on their own simulation environment, and there was pretty much no conflicts. Now, what happens if we have more of those, but we don't have it yet? So I think this is one of the challenge and the open question. So cooperation between them at this stage is limited. We cannot see those interactions. Now, the ORAN Alliance defines use cases that are based on prioritization from the operators, and they are basically defined as frameworks for XApps and RApps to address the radio resource management and optimization of the networks. And currently, the focus is based on the memorandum of understanding by the 5 European operators, is related to energy efficiency and security. This is the most important topic on the agenda for the operators. Now, again, one of the challenges that I already mentioned is a research topic is conflict mitigation. So how do we behave if we have multiple of those working together? In ORAN Alliance, there is this block, yes, that's correct, but it's empty. It's not basically standardized. This is to the vendors to define this. And then all of those could have different conflict mitigation functions, which means that the XApps will behave differently depending on what platform will you use. Another one is the use of digital twin and automation for the XApp testing and deployment. That is important from the perspective from the operator to see, and actually if it can deploy those programmable software pieces and XApps and RApps to test them and to do it in an automated manner. Now, when we were working with different RICs, we've been working both open source and commercial ones. In the open source, we basically need more knowledge. We need to know how to set up the environment, how the RIC is working, what are the missing pieces, what we could add on, that we could bypass things, and then we could do a little magic tricks, but there requires more knowledge on the whole system. Whereas for the commercial ones, we can, they provide SDK so that we can focus on developing XApps, but we don't know what is inside, and specifically if they have, and if they even have, how the conflict mitigation function works. So those are the pros and cons and the differences between them. And well, again, even between commercial rigs, they have, all of them have SDKs and APIs, but they are not yet standardized. They are not the same. So every time we want to port the XApp from one rig to another one, we need to work it again. So it's not like portable by hand. We need to integrate. I think that's one of the aspects that that Tieto was speaking. Basically, you cannot just plug and play. We need to work around the surroundings and check everything. So those are the initial thoughts from my side. And now let's move to the panel session. We will have 6 speakers. We will start with Michele Polese from Northeastern University from the States. Then we will hear from Melike Erol-Kantarci from University of Ottawa and Ericsson. Then we will have Ahmadi from University of York, Navid Nikaein from BubbleRAN and EURECOM and Open Air Software Alliance. Then we have Lars here with us in the room from Tietoevry, and then finally we will hear from Alex Jinsung Choi from Erol-Alliance and also the Senior Vice President from the Deutsche Telekom. So that's from my side, and then I would like to leave the floor to all the panelists to speak a few words about themselves. So please, Michele, if you could start, and then I will be advancing the slides.
Sure, thanks for this introduction, and it's great to be here. I'm Michele Polese. I'm a research scientist at Northeastern University at the Institute for the Wireless Internet of Things. And I've been part of this team that has been working on OpenRAN and 6G related topics in the last 2 to 3 years. So in the next slides, I'll not discuss in too many details what we do in terms of research, but rather I'll throw out some discussion points that I think are relevant to this panel. And I'll start with this question. So what's wrong with 5G, right? So it came with many promises, probably some gap between marketing and the actual technologies that has been implemented. I personally have done a lot of research on millimeter waves, which are still not there. There's URLC and D2D that have been discussed, but again, still not there. So in general, I see a gap between standardization, the general capabilities offered by research and so on, and what is then deployed. And there are some business and economic reasons for this, but I think there's also technical reasons, which is probably what we can discuss and address in this panel. So if you go to the next slide. So in general, I looking at basically from the outside looking in, my is a perspective that comes from a university lab, not necessarily the industry, but this is what I see when I look at the cellular ecosystem. So there's limited options for deployments. In general, you see that there's monolithic hardware is hard to update, to improve, to reconfigure. Very low resiliency in the sense that when something starts breaking, other systems start to go wrong and so on. There's limited flexibility in terms of what we can control and expose. There's a gap between what you can do in theory, so nice optimization, nice machine learning paradigms and tool, and then what you can actually apply in practice on the network. And there's limited flexibility in terms of spectrum, in the sense that in general, this is a spectrum that you get, this is a spectrum that you can use, and it's very hard to go into spectrum sharing in practice. And finally, there is a focus on broadband, so limited support for other kinds of traffic, and the business case is mostly for the deployment of broadband. So this is where I see O-RAN playing a role, because there's a gap between principle and implementation, especially on the control plane. So the user plane has some very nice optimizations, some and so on, while the control plane probably has been left lagging behind, and this is where ORAN probably shines. So if you go to the next slide, in general, the kind of research and direction where I think the research and industry should go is toward more open spectrum systems, where we start from the basic building block that we need to use, which is the spectrum, because if you want to do wireless, that's what you need to play with, and explore new spectrum in a new way. So with robustness and viability in mind, and doing end-to-end optimization rather than just doing stitching pieces together and focusing, for example, only on beamforming and so on. Improve the coexistence in the same spectrum. So, for example, neutral loss paradigms for cellular networks. And as we go into higher frequency bands, which I know are not of interest to the panel, but there's challenges related to coexistence with other kind of services. And finally, probably the part that is most relevant here is the more efficient spectral system. So how can we do more with what we already have? So going toward more intelligent Open-RAN, AI and ML that is actually deployable, and orchestration. So having some components that, as you were discussing in the introduction, bring everything together and make sure that the system properly works. So I think it's a good time right now to think about these things and try to rethink cellular as we enter into 6G, try to deploy it with some new ideas and some new paradigms, which I listed here. So as I was mentioning, spectrum sharing, open deployments, orchestration from the start, closed loop control, and then adopting best practices from cloud security and software. All right, so this is a little bit what I wanted to share and discuss at the beginning of the panel, and I'll be happy to continue the discussion later.
Okay, thank you. So now we'll proceeding to Melike Erol-Kantarci from Canada. So if you could just take over and introduce yourself.
Yes, first of all, thank you very much for the organizers for inviting me, and for the audience for attending this panel. My name is Mel Erol-Kantarci. The long name is Melike, but I prefer to go with Mel. I'm a Canada Research Chair in AI-enabled wireless networks and an associate professor at University of Ottawa. And I'm also wearing an additional hat in the industry. I'm the Chief AI/ML Data Scientist at Ericsson Cloud RAN product. But today's talk will mostly focus on my university research. So I will talk about how we try to coordinate the intelligence for XAPs and RAPs. So I will only focus on the RIC part of the big ORAN picture for today. And I have very few slides. Next slide, please. So as we try to embed AI and machine learning into wireless networks, we see that AI is a cool buzzword, but it can be a blessing and it can be a curse. So we really have to know how to orchestrate things with AI. And in our work that we do at University of Ottawa with my students, we came up with certain techniques to coordinate, to orchestrate the intelligence. So it's a bit different than orchestrating the RAN by using AI, but it's more about taming AI so that it's applicable in a reasonable way to wireless networks. So when we look at XAPs and RAPs that we want to make intelligent, one of the main problems is that we are trying to configure many parameters at the same time. So it may become that, and especially in a multi-vendor scenario, it may become that XAPs or RAPs from different vendors try to configure similar parameters with respect to the intents of the operator. We don't want every RAP and XAP, doing their own thing and optimizing whatever, little functionality that they have, and in the end have basically a mess of intelligence and then maybe degradation in performance as well. What we want is we want to have a team-like structure where the XAPs and RAPs, XAPs or RAPs, coordinate intelligence and they perform towards a certain goal. That certain goal could be throughput maximization, it could be reduction of energy. So in this particular work that we presented in ICC last year, we looked at how we can coordinate two XApps in which case they are using reinforcement learning. I won't get too much into the details of reinforcement learning, but for those of you who are not familiar, that's basically a technique that interacts with the environment, and it takes inputs from the environment, and we have a machine learning agent or an RL agent that takes actions. So basically a decision about configuring something in the RAN. And the vision is that we will have reinforcement learning mechanisms in different parts of the RAN algorithms. Either you call it XApp with the ORAN jargon or RAN algorithms with the traditional conventional RANs. But we will have the intelligence with such interactive machine learning techniques. So we looked at two XApps, and we tried to coordinate their intelligence in our work that we presented last year. And we showed that if the agents are able to communicate with each other and share their actions, they can come to a basic intelligence much easier, much effective than totally uncoordinated XApps or totally uncoordinated intelligence agents. Next slide, please. In continuation of our work, so we realized that, with intelligence, there is always this problem. To be more intelligent, you need more data, you need more sharing. And we know it from our personal experiences with our smartphones or anything. If you give more information to your apps on your phone, they become more intelligent, right? I mean, recently there was some rumors about some applications on smartphones just checking your iris, diluting by looking at some pictures, and then they would say, oh, the user likes this type of video, so let me push in more videos. Now there comes the privacy concern. And when it's a personal thing, it's your personal decision. But when, as an operator, you're deciding on things, you're talking about the data of millions of subscribers. So you have to be really careful about the privacy of the data and how the intelligent algorithms handle the privacy of the data. So in our future work, after the ICC work in GlobeCom, we presented something that was more for the privacy of the learning algorithms. We looked into federated learning. So in federated learning, as some of you might know, the data from the agents are not shared. The agents do their own learning, but then there's an aggregator of the model, a global aggregator that decides. So this is also some sort of taming the intelligence. So there's a lot actually that needs to be done in this area when it comes to RAN intelligent controller and the applications, XApps or RApps that run on top of them. It's important to give enough care for the orchestration of these algorithms, whatever we develop, so that they don't take conflicting decisions. We have a lot of research going on in the area in my lab at University of Ottawa. And today I'm just sampling a few of them. I think we can go to next slide now. And yeah, that summarizes basically a couple of the works that we do. And no, actually, I'm done. You can change the slides to the next speaker. And yeah, I would like to continue from here on with the questions and after listening to our fellow panelists. Thank you.
Okay, thank you very much. So now I leave the floor to Ahmadi from University of York.
Hello, everybody. I'm Ahmadi from University of York, and I first want to thank the organizers for inviting me. So basically, I'm a senior lecturer, which is technically equivalent to associate professor. It's a UK system. So at the University of York, I'm also wearing a hat at University College Dublin in Ireland still as a visiting or adjunct academic. Basically, my group is mainly working on intelligent techniques, machine learning for wireless communications, and now we are having a big focus on OpenRAN. At the same time, we are still focusing on a lot of non-terrestrial actions or activities, hands-on work. As you can see on the right side picture, basically, we have a helikite that we do a lot of experiment specifically for rural communication. And that's basically where, to some extent, OpenRAN can help us in different domains. Another set of works that I'm basically focusing on recently, well, not very recent, I would say, is digital twins and digital engineering. And as you can see, our basically group is funded by different agencies within the UK, including UKRI, Department of Science, Information and Technology, and Royal Society. I think we can go to the next slide. I have a good news that I have even fewer slides than Mel, so you will not hear too much about me from me. But again, I want to touch on a different buzzword other than AI, which is the digital twin. So what digital twin can offer for OpenRAN, and what OpenRAN can offer to digital twin. So we know that for digital twinning, we need connected devices, we need constant connectivity, we need a lot of basically overhead to keep the digital twin alive and connected to its physical twin, which can be even a service. Not necessarily, we do not need a physical entity, but basically digital twins can replicate even services. So at this case, we need reliable connectivity, which potentially with ORAN can actually have it for the smaller digital twins at the edge. And we need intelligence. So this intelligence, again, from the RIC side, can be provided to some extent at the edge, right? The next question that is coming is how digital twin can help. Well, basically that part were most about 6G, but how digital twin can help, particularly OpenRAN. And that goes to mostly to RIC side. My focus at the moment is where basically a twin of RIC can and should be created to be able to test the different X apps and R apps. Now, this replica of RIC is going to be pretty difficult, and replica of the whole network, because if we implement an X app, or if we want to test an X app, we need to have the digital twin of the full network, let it be tried on the RIC, and we see the effects on the whole system. This is basically a very complicated task. I want to highlight a few other things before I basically conclude, is the ownership. So there is another thing, that if we have a digital twin of the networks, who is going to be the owner? The vendor, the vendor of the RIC, the network operator. So these massive amount of data that is there and is going to be created as a service, which we call it a digital twin. And it enables the test of X apps or apps, their functionality, their conflicts, as Mel previously highlighted. It's a very important thing that we do not have loads of R apps or X apps that are conflicting with each other. They have different intelligence, and they are, instead of interacting properly, they are conflicting. So these, the ownership would be an issue. And also, we need to have more realistic scenarios. The final point would be the replication when we have the open deployments of RIC and the commercial ones. So we have fewer knowledge about what is in the commercial RICs are offered. So creation of their digital twin is going to be a little bit more challenging. Potentially, they would be able to provide a version of that, and we can have a look at this. Thank you very much. Again, I'm happy to answer the questions after all the panelists speak. Thank you.
Okay, thank you very much. Then we have Navid from BubbleRAN, EURECOM, and Open Air Alliance.
Yes, so first of all, I want to thank you, the organizers, Marcin and the rest, for organizing this panel. I'm really delighted to be among distinguished panelists and also the audience. And I believe that the topic we are raising the questions you highlight is a very timely topics. When it comes to me, I'm a professor at EURECOM since 2009. I'm heavily involved in open source. So I'm a co-founder of Open Interface. So we had the team ideas back in 2009, 2010. And that gave the birth to the creation of the alliance later on. And after, let's say, creating Open Interface, I was seeing already the need for an agile service platform. So in terms of European projects, the Commission set some topics related to the flexibility in the RAN, in the core. And in 2014, we had a project, European project, whose name was Coherent. It was actually looking into SD-RAN back then. And what we did, we created the first 4G SD-RAN platform, which we called FlexRAN. So it's a coincidence that it goes with the name of FlexRAN with Intel, but we were the first to put the name of FlexRAN for this SD-RAN platform. This platform got a huge success. And as a matter of fact, Mosaic 5G as well. It was used by many R&D centers, both in academia and industry, and still many are using this platform, which is only dedicated to the 4G. And obviously, we followed the activities of OpenRAN, XRAN, and ORAN, and we also worked again on another open source platform, FlexRIC this time, which was 4G, 5G SD-RAN platform. So it's complementary to the implementation of OSC RIC and ONOS. It has certain features. For instance, one thing that I can highlight from FlexRAN and FlexRIC, both of them are designed to be real-time SD-RAN controller. So from the beginning, let's say 2014, we always wanted to have a real-time control, and our use case was obviously resource allocation problem. And I believe that, as mentioned, because of the complexity of the RAN is increasing, I think RIC is there to to reduce the complexity and create an environment for the XApps to control the RAN, no matter what is the deployment. Then following, let's say, the open source activity that we have been doing, we also worked with many partners to create research infrastructure. So a bunch of universities and R&D centers across the world in Asia, US, and Europe, they have been using our platform, and we were collaborating with them to create a research infrastructure based on the open source platform. And more recently, what we actually managed to achieve is create a DevOps platform for Telekom. So to automate also the creation of the artifacts, tested artifacts, the artifacts that does not require, let's say, privilege, which also answers the questions of the security to a certain extent. And all of those, I still wanted to go extra miles and created a startup, which is called BubbleRAN. And I wanted to leverage all of this in a form that is digestible by the community. And obviously, I'm very familiar with the community of the people working on the 4G and 5G because of the open source activity we had. And I was seeing also the limitation of OAI, limitation of the SRS and many other platforms. That's why I came up with the idea of the BubbleRAN. And one of the things I saw the necessity of providing was the OpenRAN Studio, which I believe tries to solve the problem of end-to-end. So having a platform that is truly end-to-end, with a high level of realism. Please, next slide. So Marcin asked me about few thoughts. I don't want to cover all of them. I think there are a bunch of nice questions Marcin and the team prepared for the discussion, but I put a couple of things that came to my mind, and I believe we could cover some of them during the panel. So one is about the compatibility, standard compliance. So this question is a recurrent question. I want to say something that all of us know, but just to repeat a fact, that if we look at 3GPP today, they are not standardizing the scheduler. They are not standardizing the handover algorithms, and they are not standardizing the packet processing and the STAP, how the QS is actually managed. I think this is quite smart because it defines the interface, but when it comes to the, let's say, logic, it leaves it open for each vendor, each operators to do. I think that is a very nice pattern. And towards with that mentality, I believe that, for instance, if we could, there are a couple of places where we need to standardize and a couple of places we don't need and we must not standardize because to leave some room for the innovation. Towards programmability, obviously there are a lot of things standardized. I want to give a concrete example that it is proven by the result. For instance, if we look at the encoding and decoding schema in E2 and E2SM, we saw the same pattern that 3GPP has, which is the, let's say, ASN1. We saw the same pattern in SCTP that is also used in 3GPP. We also the same pattern in the E2. So these are, let's say, quite good. In some of the cases, it requires also some abstraction on the top to not limit the standard, for instance, to use only this encoding and decoding. Maybe other encoding and decoding have certain advantage in certain other use cases, because all of us, we know that 6G and 5G are more about the tail use cases, and each tail use cases has its own specificity, which brings the questions of the flexibility that really matters a lot to leave the flexibility open. In terms of the key considerations towards RAN programmability and openness, again, the conclusion I came up is that we need an ultra lean and ultra flexible platform and environment for programmability and openness. Real time is well known. Alex, Marcin, all of us, we agree that real time is important. One extra element that I'm adding is a time aware, which complement the real time. So real time means that you are at the millisecond level or microsecond level, have the same timing with the underlying RAN. The time aware is that the XApps are aware of the time in the RAN. So they can schedule things also in the future. They can benefit from this concept of the time to do some additional operations. Again, resources here is not necessarily radio resources, a RAN resource as a whole, like Spectrum is one of them, even data rate, all of them are resources. I think we need to think of a virtualization of the RAN resources for the key consideration. Cloud native, my take is must have. We really need to leverage the cloud native approach. It is shown for the heterogeneous and distributed environment. And other type of, let's say, consideration that I also want to highlight is the separation of concern between control and management. So essentially, the control subsystem for me, rig, belongs to the control loop. It is on a control domain. And we need to be mindful about the subsystems of the management subsystem of the control to have a clear separation. And last but not least, these are more for the future topics like resiliency and control delegation. What happens if the interface of the E2 is broken or interface towards the XF is broken? What will happen towards that? And there are a bunch of techniques to actually address that. So with that, I conclude my 2 slides. It was a very compressed and let's say summary of few things I wanted to share with you. But anyway, I'm open either in the chat, by email, or during the panel to answer further questions. So thanks, Marcin. I'm done.
Thank you for the insights and your takes. And now we're proceeding to our first and only speaker here at the university, which is who is Lars from Tietoevry.
Yeah, even though Lufthansa tried to not make this happen. Oh,
Sure, if it works.
yeah, even though Lufthansa tried to make it not happen, but I managed at least. So, do you go to the next slide there? So, this is me, Lars Lindeberg, from the largest company you never ever heard about, probably. 24,000 people, 2,500 people doing R&D in Telekom, working with leading network equipment providers, URAN contenders, and chipset vendors creating the software solution. I have a background as a RAN solution architect, working mostly with a little bit on the forward-leaning side nowadays. We try to be little bit, not just creating a solution that should be on the market in a couple of years, but I think we can go to the next slide here. I do like Marcin. I go back to 2015 to bring a slide. I think sort of it's good to reflect on what's really had happened or not happened. I mean, the operators still struggle with these getting enough money to be successful. And we mostly focus on optimized operations in the development nowadays, in my opinion. I mean, intelligent operations, energy efficiency, density, and the separation of hardware and software, decoupling here. This is what we talk about. But we talk very little about the new revenue streams, except we all talked about the Internet of Things as a new major revenue stream creator, but we haven't really seen that. And we talk programmability, we always talk about how to program the networks, but not that much on how do we create the new revenue streams and program that part of the network, giving access to what's the OTTs today. And at this time, we foresee 3 major things happening: network evolution, and that's a no-brainer, that's always happening. The convergence between IT and communications, and the possibility to create more intelligent and automated solutions due to the technology that's becoming available. And here we are now, 8 years later, still discussing mostly the same things and implementing it. I mean, we started with virtualization of telecom networks back in 2011, 2010 in that CNFV. And today we are there partly. So we should sort of have a little bit of a bad conscience that things doesn't happen faster. I will not be that long here, so we can move to the next slide here, because a lot of the speakers earlier have covered a lot of this area, and I agree with a previous speaker about standardization versus innovation. How much do you standardize, and how many interfaces do you really need to put into detail without sort of stopping the innovation? It sort of gets more to you need to integrate this at some level and being flexible with interfaces. That's what I believe in. So I was the shortest one, I think.
Thanks. And then we're moving to the last speaker, Alex Choi, who did have troubles to come to here from Lufthansa side. So please take it over.
Thank you, Marcin. First of all, I'm so glad to be able to join this this panel today. This morning I had a drama. My flight, Lufthansa, they just canceled my flight at the last minute, so I had to join remotely today. So once again, my name is Alex Jinsung Choi. I'm working for the Deutsche Telekom in Bonn, Germany. And up until March last year, I was the group CTO of Deutsche Telekom AG. And now I'm the research fellow and heading the T Labs since April last year. And I'm one of the co-founders of the O-RAN Alliance. Even before the O-RAN Alliance, I was one of the founding member of XRAN. And so as you probably might already familiar, O-RAN Alliance, our mission is to transform the traditional RAN toward the truly open, intelligent, virtualized, and fully interoperable RAN. So I will further elaborate that in the next slide. So once again, the background of O-RAN Alliance. It was co-founded by 5 major operators across the world in US, AT&T, China Mobile, Europe, Deutsche Telekom, and Orange, and Far East Asia, Japan, NTT Docomo. We founded it back in 2018. So now we achieved this five-year milestone this year, and today we have 32 operators globally, and if you combine their number of subscribers of 32 operator members in O-RAN Alliance, it already surpassed. It's more than 5 billion subscribers. And in addition, we have about 290 members. They are from the incumbents or small, medium companies, and the startups, academia, government agency, you name it. It's quite a good mixture of different stakeholders. So we have 4 core principles as shown in the middle in this chart. Number 1 is leading the industry toward open interoperable interfaces and RAN virtualizations. So unlike 3GPP, we are very specifically require the WAN virtualizations or O-cloud in our languages. And in our O-RAN architecture white papers, you will find the 2 architectural pillars in O-RAN. One is openness, the other one is intelligence. The topic for today's panel is openness and programmability, but in O-RAN context, programmability, I interpret it as a kind of intelligence, how to institute the intelligence. So therefore, you need a programmability. So more specifically, in the pillar of openness architecture principle, we have 5 goals, which is not shown here, but let me tell you verbally. We have 5 goals for the openness pillar. They are open interface and functions, on interoperable RAN ecosystem, and faster innovation, and white box hardware, and supporting virtualization. This is an example that how we differentiate ourselves from other traditional standard bodies like a 3GPP, because 3GPP is not so much interested in working on any kind of implementation specific topics. They don't see that's the target for the standardization. Whereas we O-RAN Alliance, yes, we are working on the specification and standardizations, but also we are very also interested in detailing out or some of the key implementation issues. So white box hardware, merchant silicon is a great example. And also, unlike 3GPP, we have open source projects, Navid already mentioned. And by the way, recently we established a strategic partnership with the OAI at the Mobile World Congress. The second architecture pillar is intelligence. I mean, as I said, I consider it as a programmability in RAN. So there we have 3 additional goals. One is radio intelligent controllers featuring AI machine learning and AI machine learning based service management and orchestration. And lastly, automated RAN deployments and operations to drive all kinds of efficiency, RAN efficiency, including energy and cost. And this is important to always have these 2 key architecture pillars in our job in O-RAN Alliance, because all the work stream it's based on these principles. And then just returning back to the chart here, the second core principle in the middle is maximizing the use of COTS, common off-the-shelf hardware and merchant silicon, and minimizing proprietary hardwares. And number 3, core principle is enabling intelligent end-to-end network automations with RIC and RFXs. And last but not least, specifying API and interfaces, driving standards to adopt them as appropriate. And we also exploring the open source wherever appropriate. So what exactly O-RAN Alliance deliver to the members? It comprises 3 packages. Number 1, it's a test specification. Technical specifications from the 10 working group, and the test and integration specification, and also necessary description about the necessary, certification badging process. We have a dedicated working group for that. And then last but not least is open source. We have OSCE committees. So at the bottom, you see our achievements so far. This is a little bit obsolete because we recently released the new packages. So far we achieved 4 release and more than 100 specification instead of 97. This is an older number. And open source releases, we released 8 releases so far. In Blog Festival, we executed it. We ran this Blog Fest already 5 times, and the Blog Fest Spring 2023 is currently running. And also we hosted a lot of virtual exhibition, and so far we hosted 381. So that's in a nutshell what O-RAN Alliance is doing and how we contribute to the community and how we drive the O-RAN, Open RAN community.
Okay.
Before I close, let me emphasize that, because I want to clarify this. A lot of people confused about what exactly O-RAN look like. So basically, O-RAN comprise 4 building blocks. One is open front hall, which we believe is absolutely critical for the vendor diversity. And the second building block is all cloud. As I said, it's for the RAN virtualizations and COTS hardware, merchant silicon, etc. And all this orchestration, cloud infrastructure orchestration and network function orchestration. And then third building block is in ORAN architecture is SMO, Service Management and Orchestration, and last but not least is RIC, you're all familiar with. Okay, that's it. Marcin, back to you.
Thank you. So thanks everybody. Now let's move to our second part, which is the panel discussion. Those are the key topics that we are going to address during the discussion. We'll speak about the future of RAN standardization, the applicability of the Open RAN networks or private networks in contrary to the nationwide networks, the Open RAN within 6G and how it fits and what are the research topics that was slightly addressed already. Open RAN challenges and maturity, possibly integration as well. And then finally, XApps, RApps, config mitigation, testing, and deployment. So I will now move to switch the screen toward so that everybody can see all the speakers. And then as we speak, I just would like everybody from the speakers to be also on video so that the people here can see you. Okay, so I have a couple of difficult questions, and then for some of those, some of the people are more, let's say, targeted, but then the other ones, and then the first one, actually, I would like to address to all the panelists. So the background of the question is that recently, and specifically at Mobile World Congress, what we get is that when we discussed with some of the operators, they have seen basically consider two phases of Open RAN adoption or ORAN adoption. That was also mentioned by Alex as the last part. So the ORAN phase 1 is sort of split 7.2 or the open front haul. This is what was mentioned as the, let's say, phase 1 related to generic Open RAN implementation. So basically, the aim here is to just work and perform similar to legacy networks. That was the main message that we got from the operators. Without any fancy stuff, without RIC, we just need it to work, and in some cases, it just doesn't. Or it's struggling for the integration and the open front haul issues. And then we have the Open RAN phase 2, which we would call advanced features, RIC and AI, and all the other things that are currently being addressed pretty much by most of us in this panel. And now my question is, how do you consider this phased approach from your perspective? Do you agree with that or not? And then how do you see this moving forward? Because from my side, it looks like exactly the split of the discussion today between openness, which is phase 1, open interface, and then programmability or intelligence, which is more towards phase 2. So I would like to start maybe as everybody appears on the screen from my side. So Navid, on the top left corner, we have you. So if you could just take this one, and then we'll proceed to the next ones. Just you need to unmute yourself.
Yeah. So you want me to take this? This is very difficult for me to answer because this is the operator's perspective. I think the choice, and because in the questions that you formulated, you mentioned some operators seeing in two phases, like so. Essentially, it depends on the operator's strategy. Even if you look at the 5G, NSA and SA, but also for the core network, we also had these two phases for 5G core network. One was leveraging the existing things, and then there was the phase 2 that was going more to the service-based architecture. I would say the main questions, if I try to put myself in the shoes of an operator, public operator, obviously not the private, because for me, those are completely two different things. An operator essentially takes the example of Orange, France. So Orange probably has, let's say, a mixture of solutions from Nokia, from Ericsson, that is deployed in maybe back then from also Alcatel-Lucent, deployed in France. And now let's imagine that they are upgraded. So Ericsson comes with its own near RT-RIG and XApp, and Nokia comes from its own. And then Orange comes with a non-RT-RIG and the R apps. So I tend to say that, as you mentioned, the interfaces, let's say all of those are specified, but when it comes to true programmability, it is quite challenging to validate in a real use case. And I can make a link to recent agreement between Vodafone and Orange in Europe. They want to do the RAN sharing in a rural area. So this obviously, with using Open RAN, obviously this needs the programmability. And my take was that, okay, if they are gonna do this in a rural area, obviously they want to, first of all, minimize the risk at certain point, right? And second of all, they want to do the RAN sharing, so to minimize the CapEx and the OpEx. So it means that there is a risk that operators are seeing, but they see a huge also benefit and advantage, and they need to go to the pilots. So the best location to start the pilots seems to be rural area. This is, again, my interpretation. And I think this is a good sign that operators try to validate programmability in a smaller scale, right? And more than that, I can also tell you that operators also try to see the applicability of some open source component in the rural area as well. Not in a hot spot today, because obviously about the risk, all of us, we know if one of our HSS or AUSF or UDM, they go down, it's a huge impact on the subscriber. So I would say, I see from my limited perspective that operators, the big tier one, let's call it tier one operators, try to go one step ahead. Agreement made, public announcement made, target area is made. Also, they are considering open source. So it seems to be that the phase 2 that you were talking comes with little programmability on the RAN sharing, and also a lot on the validation part. And again, to conclude, this would not be the case, in my opinion, for the private 5G deployment, even though that private 5G network is deployed by the public operator. Yeah.
Okay, thanks. Yep, so I agree, sort of, meaning maybe I was not fully clear. It is more for the wide-scale deployment. The programmability is on a second stage. Mostly, I would say, because as all of us mentioned pretty much, or at least the first 3 speakers, about the issues with conflict mitigation, and then going to the real, let's say, testing and digital twinning of all the XApps, how they will behave and how you would actually validate those different aspects, and if there are or not the different XApp stores and all those testing issues. Of course, for the proof of concepts and for the small scale implementation, and specifically for private network, I would agree with you that this is a different story. But let's move to the second opinion, and now we have Alex in the queue.
Yeah. So okay, so two-step approaches seems quite plausible, you know, but the reality is much more complex. We have a greenfield operator, we have a brownfield operator, we have operators, you know, greenfield operator like a Docomo who directly start to deploy ORAN front haul compliant ORAN network vary from, from the beginning, from at their metropolitan area, not the rural areas, whereas other operators, they started from the rural areas or even enterprise networks. It's kind of a cautious approaches, but anyhow. So, and also some operators more aggressively deploy already the legacy, self-organizing network, either centralized or decentralized, so they have some sort of, RIC or accept like, automation optimizations, software already put in place. So what I want to say is the reality is quite complex, and different operator have a different strategy and different network deployment scenarios, etc., depending on their assets available, spectrum, cell sites, fiber, dark fiber, and etc. For the greenfield operator, definitely it's much more easier for them to go with the whole ORAN packages, open front haul, SMO, RIG, all cloud, RAN virtualization all together. So looking at the Rakuten, Dish, and their, this is their approaches. It's like a big bang approaches. And as I said, brownfield operators, they are facing more challenges and more options. And also, you have to consider how many vendors you really want to bring, and so depending on your preference in terms of the number of vendors, also it has impact. So that's all I want to say.
Okay, thank you. So now we have the second row, and it starts with Lars.
Okay. Borrow this one. Well, there is a big thing with ORAN, though, the maturity itself. And my impression is that there's quite a way to go, not be close to the incumbents with tier 1 apps today in functionality, in performance. So for the greenfield, it makes sense. For the brownfield, well, they also have the option to go with the big ones, cloud run solution for then moving on to ORAN later. So I think we are in the phase, get the basics up, get something works with decent performance. I mean, there's so many levels you can differentiate on, and what we see today is more or less basic implementations of basic networks with standard VDPP, no extra bling bling. So the X apps, the OR apps, I think that's a little bit further in the future. That's my impression.
Okay, thank you. Now we have Mel on the line.
Well, thinking about the phased approach, I agree with Alex that it really depends on the operator. But at the same time, we're talking about a very complex system that has been integrated before. And now we are making it disaggregated and then giving efforts for integration and also taking care of security. I always see this as, you have a well-fitted, tailored dress, and then someone comes up and says, hey, you can have a better color, you can have better sleeves, so let's, change those. Okay, you stitch them back, but then you have to try it on and see if it's as comfortable as before, and it's also like what you need. And stitching back properly is really, really important. Otherwise, you end up with a very uncomfortable dress or a jacket. But I think here, when stitching things back, your thread and needle is really important. And putting AI in the second phase is something I don't know, maybe I'm a little bit biased about the area because I'm very enthusiastic, but I feel like it wouldn't be the right approach. AI is not an advanced feature. It's not this, cherry sauce on top of an ice cream, in my point of view. And we see this from another industry, from the automotive industry. When they're making the self-driving cars, of course, the goal is to reach the capacity, the speed, acceleration of the traditional cars. But at the same time, it's more software-based. And when they are developing their self-driving cars software-based, AI plays a fundamental role because things are becoming more complex. So a phased approach is feasible, but how you put out the phases, I think it could be a little bit of up for discussions. And, with the recent advances in the area, both in wireless and AI sectors, industries, the picture might change a bit.
Okay, thanks. So it seems so far that I was oversimplifying, except Lars, nobody agrees. But let's have a quick shot from Michele.
Hey, so in general, I think it's a matter of definitions, because you can probably have programmability even without the openness. But if you want to do it in a very flexible and customizable and sort of in a plug and play sense, you need to have open interfaces. So the phased approach for established deployment is probably something that makes sense. However, I think it's important that while we focus on interfaces, open and so on, we don't forget about the other part, which is really what's exciting, I think, about the O-RAN paradigm. And I think it's important to start testing and developing programmable solution from the beginning, right? Without programmability becoming an afterthought, something that you put on top later and may not even realize. So in this sense, starting from maybe private deployment, starting from testing in experimental testbeds and platforms, I think it's something very relevant and important.
Okay, thank you. And then finally, Ahmed, what's your opinion on this?
Well, it's very hard to be last, everything almost said, but I just want to highlight a key point that in the phase approach, one thing that is very need to be considered and is considered by the operator at different sizes and even when they are starting deploying is that when we go for softwareization, the interoperability is pretty important. And now we have different vendors, even smaller SMEs providing X apps or even different brick versions that can be there. So when their updates are out, they can have their own conflicts or patches. So the system that currently works like a dress that Mel mentioned, it can, with a new update, it can be a different one. So at the very first, we have to consider all the phases need to be considered properly. Additionally, I also think that can be a fair approach if the operators at different sizes start with the rural deployment, as many of them in the UK started the O-RAN projects within the rural areas and then move towards the more high density deployments, at least in the UK government approach that we are aware of that. Thank you.
Okay, thanks. So now that thank everybody for speaking out their mind. Now I have some questions to specific people that are more, let's say, addressable for those to address. Now the first question I have is specifically to Alex, because he's the one within the standardization body. So basically, what do you foresee as the next steps for Open-RAN standardization? I have seen that at Mobile World Congress you were sharing some of those. If you could also share it here and maybe comment a little bit. So what's next for the standardization progress?
Okay, I mean, firstly, it's important for O-RAN Alliance to make O-RAN specification, which is considered as a de facto standard, to be adopted by the official national, regional standard bodies. for example, EDGE or ATIS in US, and arrive TTC in Japan and TTA in South Korea. So that's exactly what we have been working on since last year. And we quite successfully convinced or agreed with the EDGE standard bodies, European standard bodies, and they agreed to adopt all the ORAN specification. But due to the difference between the two organizations in terms of the specification document template, we had to some reworks, not the contents, more like formatting and etc. So that takes it's a little bit time consuming because our document is already quite heavy. So we already delivered first delivery was more about the working group 4 specification, which is the open front hall, which we believe is the most matured document in ORAN Alliance. And then we have other documents specifications in the pipeline. So we are targeting to deliver all the ORAN specification to EDGE before the end of this year, if possible. So once again, this is a very time-consuming task. And on the other hand, the specification-wise, our focus now is more on, as Marcin, you addressed in the beginning, in the opening, security and energy efficiency. For the energy efficiency, we just launched a dedicated working group to work on it. And also security, this task group has been running quite some time and started to publicize their specification and also technical report, which is a very worthwhile to take a look at it because the recent delivery includes all the necessary security analysis and the measures with regard to accept RF's risks. So it's not fully complete yet. It's yet to be a technical doc report rather than a specification. So that's also another important priorities. And having said, one additional priority for ORAN Alliance is how we can harmonize with the 3GPP. So we have established some kind of MOU with the 3GPP, and but then the devils are on the detail. So our plan is to participate their next RAN workshop for defining all these key work items for the next release, which is release 19. This workshop will be held in Taiwan mid-June. So our plan is to, bring our contribution and then attempting to, to harmonize with the 3GPP. Yeah, but some, as I said, the work scope with regard to the target standardization target is not exactly same because they are not interested in any implementation related topics, whereas we are interested in implementation related topic as well, because otherwise the vendors, they always come back and asking a lot of questions for clarification and also guidelines from the operator members. So we expect this demand from the vendor community. So why don't we just proactively develop such kind of a guideline, implementation, reference model, open source, and provide all these things so that they can save time, they can save energies, and etc. So those are the 3 priority issues when it comes to the next step in the standardization in ORAN Alliance.
Okay, thanks. So I have a follow-up question. So when we are speaking about the ORAN Alliance specifications entering or speaking with 3GPP to incorporate that, do you see that OpenRAN or ORAN Alliance as such with its specifications will be incorporated fully within 3GPP in the 6G timescale, or do we still have separate specifications and 3GPP will not want?
Yeah, I mean, it's 6G, absolutely yes. Even before 3G, they say release 19. So release 19 and the release 20, probably it's still part of their, advanced 5G specifications. So our ambition is to harmonize the ORAN specification with the release 19, release 20, which is 5G advanced. For the 6G, yes, that definitely, but honestly, I still don't understand what exactly 6 will be, at this moment. So still it's too early. That's too early.
Yeah, thank you very much for this insight into what's happening currently. And then actually now I would like to switch over to the colleagues from the research community, which is Mel, Ahmad, Michele, and to some extent Navid. So what are the current OpenRAN research topics that you are addressing and that you are thinking about being important? And we can start then again from in the opposite direction, and we now have Mel on the right hand side, so we'll start with you.
All right. I think one of the biggest challenges and interesting areas when it comes to ORAN is again related with AI and programmability. But something we need to be careful there is when we introduce AI for addressing complexity, we should make sure we're not introducing new complexities. So in my research, with my research group, we focus on the detailed interactions of AI-enabled algorithms, like the ones that I showed at the very beginning, team learning algorithms, where multiple vendors, multiple players can come up with their own XApps, and then they can work in a coordinated manner. Even with a single vendor case, these kind of orchestration issues need to be managed. Other areas include privacy or securely information sharing among the XApps or RApps, because again, in a multi-vendor setting, this can be an issue, but even a single vendor setting, that means using operator data to optimize algorithms. So how do you securely share information and take care of privacy? I think these are very important. And then trustworthiness and explainability of the use techniques would be the third thing on top of my mind, at least in terms of hot research topics. You need to be able to explain how your system behaves when you're using machine learning algorithms. Sometimes it's not as straightforward as traditional algorithms when you have a neural network and the background running and continuously changing its weights based on basically trial and error type of algorithms. So all these things are very important for making AI, machine learning, and RIC intelligence part of RIC applicable to any kind of RAN management, in my opinion.
Okay. So thanks again for the insight, and now we'll move to Ahmed, so that you're not the last one again.
That's good. Thank you very much. But it's actually very interesting to see. There's a lot of overlap with the work that we are doing in ORAN at my group and things that are happening in Canada with Mel's work. And potentially I'll see Navid will address almost the same thing later on. I want to start with one thing that was not addressed in the AI work is energy efficiency. So till now, when we train algorithms, we let the algorithms learn from the massive data that we potentially can get from the operators. Then this will help in two ways to the energy efficiency. Of course, when we do a better resource allocation and planning, we make the network to become more energy efficient. But at the same time, the training of these AIs will take a lot of energy as well. So one thing that we are looking at an EPSRC funded project is the energy efficient AI algorithms. So to reduce this level of training that we are using. One of the approaches that we are looking at is transfer learning, where we are basically using our trained models to face new environments. And in these new environments, we with fewer amount of data and training, basically the model that is trained in a different environment will become compatible with the new environment. The other works that we are currently focusing on is explainability, because it is, as mentioned, it's very important to the operators, smaller operators, local, private, the ones that they are focusing on a certain application to know what the AI is doing. So if the AI just recommending some work without and changing the weights and doing different things, the things that they do as a black box, of course it is acceptable, but it's not that much trustable, especially the operators and in the local communities specifically. They need to know what is happening, and then they will trust it better. The privacy and basically trust in the data sharing is another thing, specifically when we are looking at the scenarios like the deployment of O-RAN for neutral host systems. There we basically need to let the users and operators know that their data is used for training the algorithm in keeping the privacy. Similar to what mentioned, we are using federated learning to train the models separately and then aggregate the trained models to reach the better result and fed it back to different agents at different locations. So these are the current trends that myself and my group are looking at with respect to AI within the RIC and at the different levels of X apps and R apps that we are working on. Thank you very much.
Thank you very much. Thanks. Now we have Michele.
So I guess everyone is doing explainability, so I'll skip that part. But I also think it's a very interesting topic and something that needs to be addressed. And it also really connects to the conflict mitigation component. Because if you know exactly what your XApp is doing, you can try to either prevent conflicts or figure out that there's a conflict, you can do something about it. Something that I like to mention is, as researchers, I think we should always try to look at what's next, right? What's beyond, what's phase 2. And something that we have been looking into is how you can extend your architecture to additional domains. For example, something that has not been discussed in, at least to the best of my knowledge, in the context of O-RAN is integration with integrated access and backhaul, which is basically a self-backhaul technique for 3GPP networks. And there you don't just have the access that is wireless, you also have the backhaul. So there is an even larger parameter space that you can optimize and programmatically try to control with O-RAN. So something that we've been doing is basically discussing the architecture and what you can do in terms of control of AIB with O-RAN. And the other piece is how do you safely and practically extend your architecture to domains, and specifically the O-RAN control loops to domains that are not considered today. And so the real-time control loop component, how you can integrate plug and play components into DUs and CUs. So similar to XApps with the idea of the apps, which are components that you can deploy directly in DUs and CUs and do, I wouldn't say similar, but related kind of control with the XApp. So we've been working on this from a system level perspective, so trying to consider optimizations that you can distribute across different components and orchestrating the intelligence, in the sense that it's not enough to deploy a single component somewhere, but you need to have some sort of orchestrator that can balance the deployment of the intelligence and can manage where the different pieces needs to be deployed. The other piece is testing and infrastructure, but it's more related to how you deploy and test these tests rather than research itself. So maybe it's better for another question.
Okay, thanks. I have one more question actually to you for the DApps, because that's the following one as well. But the question is, do you see this as a real-time RIC, or how do you embed that into CUMD? There is some kind of abstraction to do so.
Yeah, so the primarily I see these as standalone plug-and-play components that can be interfaced with XApps through the near real-time RIC, but do not necessarily need too much overhead to be deployed inside the DUs and CUs. Then the implementation itself and the structure itself, of course, needs to be in some way designed to be independent on the specific implementation, in the sense that base stations from different vendors are different kind of software solution and implementation. So something similar to what the two service models are doing, I think, is something that should be replicated here. And the other advantage that I see related to the apps is the possibility of, again, given that we're running into the DU and CU themselves, doing some sort of inference and or classification or prediction based on data plane information, which is something that you cannot expose to a RIC because of security, privacy, and practicality concerns. So we've been doing a lot of research on basically inference based on IQ samples. And with DApps is something that you can practically transition into the RAN, while you cannot, of course, move IQ samples out of a base station.
Okay, thanks. So finally, the same question. So what are the current research topics, Navid? Over to you.
Thanks for the question. I join Michele for what he said. We have been thinking a lot about the RAN abstraction as a whole. So how the RAN resources, again, resources is not limited to radio resources, could be abstracted to provide the required flexibility for what it comes next. The idea of plug and play for the E2 node, we validated in FlexRIC. So FlexRIC service models, all of them are pluggable service model. So based on the actual use case, we could plug the service model that we require, whether that service model is specified like KPM or RC, RAN control, or whether that service model is custom service model designed for a specific use case. So that comes to the service model, but a service model for me is just the interface. It's not the logic itself. When the DApps comes to the picture, and that has a link to the RAN abstraction, I'm essentially thinking of I mentioned back then this control delegation that we validated in FlexRAN back then for GST RAN. So control delegation comes in a scenarios where the centralized controller is overloaded, or the backhaul link between the E2 node and the RIC is not ideal. Maybe it's wireless. You know, we cannot assume that the link between the E2 node and the RIC is always an ideal link. So in such a case, it might happen that the RIC delegates part of the control. When I say RIC, I also include the XApp to the E2 node. So towards that, I believe that E2 agent has more potential to act to become more active element as opposed to what it is today, which is more passive. Like, obviously, it has an interface to the vendor, it has a service model, but it's not actually has any decisions to make. And under certain scenarios, example, non-ideal backhaul between E2 to the rig and many other, maybe the real-time problem is another one that you really want. I mean, when we talk about 6G, we need to really think that we are talking below 1 millisecond as well. So again, it might happen that we cannot really sustain even sub-millisecond level latency. So I believe that E2 agent, there are a bunch of research we could do on turning E2 agent into more active or even proactive entity, right? Which goes through the discussions that was there. I think cloud native behavior, and more specifically for XApps. I mean, XApps, there are a bunch of research areas that we could do on XApp, but cloud native, it's an easy research, but still there are so many details to consider for XApp. And I want to terminate with this. I'm thinking that when is the end of specifying service models? Again, from the research perspective, not from the let's say standardization, deployment, and operator, but from the research perspective, I'm asking myself these questions. Could we design a programmable service model, a unique, just one, unique programmable service model that could accommodate any need based on what XApp requires, as opposed to say we are having a bunch of, we have several service models that are specified. There are some flexibility when we want to define the data model inside. So that for me creates a problem of flexibility, because then you need always to mix and match bunch of service models to do what you want to do, as opposed to say that unique programmable service model, I really design it, program it to have exact data that I need to perform the thing. So these are, again, goes to the RAN abstraction, this discussion. I think there is more to be done on the programmability of the E2 node itself that could be beneficial for the XApps and the rest.
Okay, thank you. So now I have a question to Lars. What from your perspective, what is the biggest challenge for OpenRAN from the integration perspective, but also for the actual deployments and the sort of getting back a little bit to the initial question we had?
Well, looking at reality, I mean, there's a lot of interesting promises we will run. But just to reflect on this thing, we talk about RApp, XApps, DApps. It's a very tempting concept having your app store here, right? But who will be responsible for making sure that each app is secure, that you don't let a Trojan into your network? Based on my earlier experience with operators, that they normally ran every release in the labs for quite a while before they let that out in the wild. And how do you create a solution that you can troubleshoot today with all of these components coming from different people? How do you really do that based on field experience? That's quite an interesting challenge. So there's a lot of things here. We will be going over on, but when? That's the question. And where's the maturity right now? The concept is excellent, I would say, in the long run. I don't know if that's was an answer you're looking for, but sort of.
Okay, thank you. Anybody wants to take it as well? Anybody wants to complement?
Maybe I want to add on. No, I want to add something, for the last comment, I mean, the accept RFs, lifecycle management, and all this workflow and etc. I mean, this is not the first time we face such challenges, including the security. I mean, when the telco industry started the journey called the NFV, Network Function Virtualization, this is exactly, they faced exactly the same challenges. And then it took quite some time. They came up with a very reliable CI/CD DevOps pipeline, including all this, lifecycle management of the, VNF and now CNF. So therefore, I think our industry acquired quite a good lessons learned, and also figured out how to deal with these challenges. So therefore, it's not the first time. So we have to apply the best practice from our NFV journeys, and then apply for the RIC platform. Conceptually, I don't see any big difference.
Yeah, just a question there, though. What was the last thing that was addressed in at CNFE? And that was for security.
So, yeah, just for the security, like I said, we Orient Alliance recently published, publicized the technical report for analyzing the security aspects of RIC applications, accept and RFs. So we took the first step. So this is the first step, and the more step will be taken this year.
Okay, thanks. I want to go back to the topic that Michele and Navid already mentioned, which is the real-time apps, called the D-apps as well in the research community. The question is to the other panelists, which is to Hamed, Mel, and Alex. Do you think that ultimately they will come within OpenRAN beyond research? So the functionality below the millisecond control loop, and especially the same question I had to Michele, which is, do you think that there will be a real-time RIC, or do we embed those in the sub-millisecond or millisecond level in some other form for scheduling, link adaptation, beam management, hybrid ARQ, and things like that? And now I would like to start with Hamed.
Very interesting point. So basically, I think, as guys mentioned, so we have to do something to DU and RU. So basically, if we can embed the intelligence at the DU and RU level, we will reach the sub-millisecond. But personally, I don't think we are going to have a real-time RIC, because the distance that is going to have from the edge of the network is going to be longer to tolerate that level of latency that we require. That's my personal opinion. With a little bit work of the industry and the companies that we are working, we see that the necessity and the need to further embed some intelligence at the basically the DU and RU at some point. But when we are reaching that, I'm not sure. Thank you.
Okay, thanks. Mel?
Well, I think I want to take RIC a little bit broadly than the ORAN specs, and lay it down as a general controller, regardless of the time scales. And when it comes to that, we need to, I think there is a need for a controller for sure, for even the fastest loops that we are talking about. Whether you do it with separate XApps, it's a controller of the XApps, or it's a controller for one XApp per XApp, so which comes down to maybe having the intelligence per algorithm, you'd still need some unifying platform to have all the intelligence interact with the other intelligence that's happening elsewhere in the RAN algorithms. So the naming could be different, the timescales could be different, but some sort of a platform, I think, would be needed.
Okay, thanks. And now to Alex, but maybe I will add a little bit more comment in that context. I think the issue here is what do the big players think about that? Because I think that's one of the reasons why we don't have it yet. Because basically Nokia and Ericsson don't want the scheduler operation to be controlled by someone external. So this is the question a little bit towards the standardization part.
This is a very, very tricky question. And there is a technical part and there is a non-technical part. Because if you really want to deeply disaggregate and open up all these internal algorithms or interfaces, or close the APIs, then you will face a lot of, how can I say, some industry players, they will push back, So, our goal is to drive the ecosystem toward a healthy and productive and mutually beneficial ecosystem. Even though this is it's a little bit idealistic, but that's the missions or an alliance. So we don't want, one hand, we don't want to too much disrupt the whole industry landscape. At the same time, we want to drive the technology innovations. And so that's what I mean by it's a little bit tricky. And also, openness also always comes along with the multi-vendor support. So if you want to support the multi-vendor scenario, then you have to introduce open interfaces, open APIs, and disaggregate further and further, deeper and deeper, horizontally, vertically, and then you bring the interoperability, test specification, certification, and all this, and then for the system integrations and end-to-end testing specification also is necessary. So the more you disaggregate it, you tend to increase the system integration complexity for sure. So, and there is associated cost. So we have to keep the balance. And also when it comes to the rig, still I have to admit, it's not fully matured yet. So let's make sure you can walk before you run. So that sense, non-real time first, and then after we gain a lot of, we get the proof points and the experience and more knowledges and insight, and then you move to the next phase. In this case, it's a near real time or truly near time, real time, which is less than 1 millisecond, which is quite ambitious. So our thinking on behalf of operator members is let's take more cautious approaches and more careful. But at the same time, we have to also understand there is a growing sense of urgencies. For example, energy efficiency, massive MIMO, how to better support the multi-user massive MIMO. And to do so, you have to apply the dynamic beam management. So considering once again, the multi-vendor scenarios, some sort of, open interfaces, open API in near real time is absolutely necessary, not in the future, but in the really, really near future or tomorrow or today already. So it's kind of a tricky situation.
Very cool. Thanks. So you basically say that it might pop up in the future in, let's say, the ORAN Alliance specifications that going further down to millisecond level will be possible.
Eventually, it will happen, but I'm not sure exactly when.
Okay. And then before we open up because we have 20 minutes, I think, left, before we open up the floor to the audience to ask questions, I have one final one, and we'll start with Lars. Do you think that we will end up in one platform, or two platforms, like Google Play and Play Store for the X apps and R apps, that will be totally, let's say, independent on the underlying rig, or the rig will be the store, or rather we will have the conglomerate of companies with dedicated XApp stores and specific rigs that the companies would need to basically develop the XApps towards those, and even more going further, pay for being on those stores. So they will be tightened to the rig, or completely independent.
That's $1 million question, I guess. The thing here is that when I read about the rig the first time, I was under the impression that that would be one platform, not 10 platforms you need to adapt to with your X apps and R apps, right? So the idea of the App Store is quite tempting, as I said, but problem here is if you compare to your phone, how many of your apps interact with each other? And so you don't have conflict management in your phone, as an example. Where either Apple or Google take care of making sure that your app is secure, even though TikTok slipped through with all these data leakage and so on. So if the concept should be successful, you need to have such a solution, but in which format, it's impossible to say today. It depends on operators, I would say, which stance they take. I mean, look at it. Top 5% of operators have the capabilities and muscles to do a lot themselves. The other 95% will just follow, take the easiest road, because they don't have the money or the muscles.
Okay, thanks. Navid, what's your take on this one?
Yeah, I can actually say a word because I give courses on mobile application. So if we look at the ecosystem of App Store as a generic term, not Apple App Store, obviously we saw at the beginning that there was main platform providers. They were providing the portal for the application. So you mentioned it, Play Store and App Store. But more recently, when I say more recently, it's already a couple of years, we saw that there are many more stores that come to the play. I can name, for instance, Amazon has an application store, or Samsung has another store that they introduced. Even the car manufacturers like BMW, Renault, or many more. I just give examples that I have for sure, is that even BMW, they have their own store for the application that is running on the car. So I'm not seeing, and I think even if it's an advantage to have multitude of the stores as opposed to a single store. The whole point about single store is the trusted and simple portal for taking the XApps. Yes, that we can say, but it's like a walled garden. Like you have a beautiful garden that you're having a wall. I see more stores specifically when it comes to the private 5G more, because if we look at the 5G use cases, the tail use case are the dominant use cases. And I have hard time to believe that all of these tail use cases, we could match them into certain specifications in terms of XApps and in terms of the service model. So my take would be that there is a need for customization. When that customizations come to the picture, naturally, we need more stores that are more specific for Industry 4.0, more for IoT, more for public operators, and so forth. I'm not saying single portal is bad. It has many advantages, but I don't think that it solves the problem.
Okay. Anybody else want to take this one as well, or?
Yeah, maybe, yeah, I can make some comment. I think it depends on the operators, because if operators proactively make an investment and build their own XApp RF marketplace, then there is a possibility that we end up having not too many marketplaces, XApp and RFs. But if, operators, they don't want to make that investment, instead they just delegate everything to their vendor partners and going through the traditional RFP process. So you run this RFP, RFX process. So bring your dear vendors, RIC platform vendors, please bring your proposal, making sure that you have a sufficient XApp RFs supporting running on your RIC platform. Then vendors will incubate their own ecosystems immediately. So that's how you get all this vendor-specific RIC, vendor-specific SDK, vendor-specific marketplace. This is exactly what happened when we, once again, back to the network function virtualization journeys. So, I mean, so we had to learn lessons from the, network function virtualization's, experience. So, but again, I'm not so sure operators will actually, they are more interested in the SMO for sure, because they want to build really end-to-end orchestration, automation layers, ranging from, all the way left, radio access network to the right, which could be service platform and core network and etc. So SMO is a more higher priority, but operator RIC platform or common RIC or federated RIC platform developments, at the moment, I don't think that this is a priority for operators. But I want to urge, operator community, at least the ORAN operator members, to prioritize the common, federated RIC platform for the sake of the whole, operator community.
Okay, thanks. Anybody else?
I have a question, Marcin, related to what Alex just said. If we take a country and let's say we have, a given country, each country has 3 or 4 public operators. I have no idea how many RICs are going to be deployed. For instance, take an example of France. You have a couple of operators. Are they going to have 1 RIC per operator, or 1 RIC per operator per vendor, or 1 RIC nationwide? How this is going to play out, to your opinion, Alex, or all the panelists and the audience?
To me, especially if you go in the near real-time domain, 1 RIC is probably not enough, because at some point you start having scaling issues, and you need to handle thousands of base stations with a single platform. So for the near real time, I see it being deployed in multiple markets, probably in the same country, but no real time, probably 1 is enough.
And I think also depends on the delay, right? So you need to have to handle this 10 millisecond delay. And then in addition to that, it doesn't make sense for me if you have one base station handled or sitting in one side of the country, and then the other one on the other side of the country being handled and analyzed by the same rig. So from two perspectives, I would say.
Yeah, that's a very good point.
Okay, so I think, well, I have 1,000 more questions, but maybe we can give the possibility so that the audience can ask some questions. So I think that Navid was also answering some of the questions from the Q&A session. I will check them out, but maybe here in the audience, we have anybody. Thank you.
It's Adamczyk from the Poznan University of Technology. So first of all, I'd like to thank all of the panelists and the organizers for the great discussion. I would follow up my question to what was discussed just now. And from the perspective of multiple MNOs operating in the same network, having some of the base stations collocated in the network, how would the intelligent RAN control coordinate between their networks? Would there be multiple non-real-time rigs who would coordinate that and would be integrated in some way, or would that be through the SMO framework level? Thank you.
Okay. Anybody wants to take this?
I think it's a very good question. It depends on how much the different operators are sharing the resources. If we're primarily sharing the RAN and not necessarily, for example, the spectrum, I still see independent rigs as a viable solution. Instead, if there is a tighter engagement and, for example, also spectrum sharing among the operators, I think there needs to be some solutions to coordinate. In terms of research, we did some research on like neutral host solutions and platforms where you have a third and independent provider that basically provides the infrastructure, the rig itself, and deploys the XApps and services that the operators require, and also allocates spectrum allocation to the different operators. I think this is an interesting paradigm, especially when you want to go into new markets or private 5G deployments where sharing can be a way to cut down the costs. I don't know if the other panelists have other ideas on this rig sharing component.
I think it will highly depend on the purpose of the RF on the rig, especially the near real-time rig, I guess. That's what the question relates more to. Let's say you have a weather prediction RF. I mean, that could be for any operator within the region that's more, geographical region-wise, some information you could share. But if it's specific to the network configuration, then it would be per operator. But when we look at the platform, then how do you run all these, different sorts of RFs touching upon different things? Then that becomes a complicated story, and coordinating different RFs that are deployed on different platforms will definitely be an issue then.
Thanks. Anybody else? Okay, then we can take the question from the Q&A in the chat. So we have one question. Let me read it out loud. Do you think that XApps in O-RAN will be used to perform RRM, or rather they will be used to optimize RRM that will be executed up to E2 nodes? Are there any solutions for centralized conflict mitigation? And is E2 SMRC completely standardized? Are there any rigs that fully implement it? Anybody else want to take this one?
I can take the last one. To my knowledge, today, none of the existing open source rig implements all the service models. For instance, also we need to be mindful about each release of the service model. For instance, there is also a KPM version 3 as well that has been released. So this is ongoing. I would say the implementation of the service model, I don't think it's a bottleneck at all, because that comes with some engineering effort to develop it for a given platform. And it's really not at all a problem. I would say the problem relies on the RAN function that should support that service model, which may not be available on at least the open source. If you take the example of SRS, OAI, or implementation of OSC for some of the RAN functions, a lot of functionalities, fancy functionalities that we would like to have, because we talk obviously about AI-driven XApps, some fancy decisions which are, let's say, Marcin, you yourself said, okay, we are using the SDK is abstracting. Yes, you get some results, but how you are sure that in a real system, how it will gonna behave? Because SDK is essentially simulating a bunch of things that you don't know how it's gonna work in real life. Now, example of OAI that I can give you, also I can give the example of SRS. If you are interested in traffic steering, which is the primary XApps that is very well known, either you want to perform the handover. So essentially you need to get some statistics, which are easy part. You can get some statistics through the KPM, and then you want to enforce the policy for the handover, for instance, or for some other thing. So that already means that even though the service model supports the handover, the RAN function must be able to execute it and must be able to fail over if that control command that you are sending came to the RAN in a bad moment. The UE cannot connect to the target cell and needs to fall back to the source cell. So what I'm trying to say is that the actual implementation of the RAN function are the key to give the power to the XApps to perform the control through the service model. So that is where I see difficulties much more than seeing in the service model.
Okay, thanks. I can complement this with a little bit of background. For this E2 service model, are there any rigs that fully implemented? So basically our experience is that actually the rig doesn't have to implement the service model. It's the XApp that needs to take this into account, and the RAN control or the RAN node, which is E2 node, that needs to implement that. And the actual rig needs to pass the messages to the XApps. And this is exactly what you said, Navid. If the E2 node does not implement it, then you cannot actually make this action. And this is what we were also struggling with when we wanted to implement the traffic steering. But the service models in the underlying E2 nodes doesn't support that. And the rig doesn't have anything to do with that. So it's more to the CUDU vendors to implement those service models and expose those through the rig so that the XApps can subscribe to those. And then there is the second question. Do you think that it will be possible to have simulation environments to test potential benefit of the ORAN paradigm, conflict mitigation between XApps, due to high cost and complexity of implementing possible solutions on real equipment? Anybody would like to take this one?
I'm answering too much. I don't want to say talk about all the questions, but one of the objectives that I was working with the OpenRAN studio was to exactly do what you just asked, to make sure that we do have an end-to-end platform, because one of the missing pieces, in my opinion, is to have an end-to-end platform. When I say end-to-end, it means that you have a user equipment in the loop connected to the on 5G to the base station and connected to the rig, connected to the XApp. Traffic is ongoing, user plane traffic is ongoing. Data monitoring is coming to the XApp, decisions could be made, and then some deep analysis could be made. So the idea of OpenRAN Studio is exactly to enable this end-to-end and ORAN stack. And the supported platform today is we are supporting OAI, we are supporting SRS, and we are supporting Ahmadi Soft on the top of this OpenRAN Studio. Yeah.
Mm-hmm. Yeah, I agree with Navid. It's important to have platforms that allow you to do the end-to-end data flow from basically from the data collection to the experiment itself, when you validate if the XApp is working.
Okay, so I think we have time for just one final question, and I would address this to Hamed and Mel. So the question in the chat was that my question is about ORAN with 6G. There is a notion that 6G will be AI native. Thus, almost all components of the 6G architecture would be equipped with AI functions, whether for networking, AI for AI or AI for networking. And then we have the rig in the ORAN that in a way provides intelligence. My question is there not going to be some kind of overlap if we have the rig and the AI and the inbuilt AI function in the same 6G architecture?
Maybe I can take it first, but I'll be very brief because of the time constraints. I think even before it comes to AI, the interplay between 6G and ORAN, we still don't know how it's going to be panned out. We are at the very early stages of 6G research, and then there's going to be the deployment, new releases and everything. And of course, we expect AI to be an integral part of 6G, and we expect AI to be an important part of ORAN as well. But I think the main question lies in how will ORAN Alliance and 3GPP will align, and then how the 6G standardization and ORAN standardization will align. And that is a matter of time. Unfortunately, I don't have a crystal ball to say, when things will come to enough maturity, but I think it's all for us to watch and see how the advancements are happening. And I think it's one of the reasons why this is a very exciting time to be doing both research and development in the wireless industry, because things are really at the very core of things, and they're very hot. There are a lot of new research ideas going. So I believe this is why this area is so exciting and it's creating so much buzz.
Okay, thanks. And then the final word by Hamed.
Yeah, so I want to echo the same words. Basically, we don't know how OpenRAN is going to be integrated in 6G. When we know more, it will be clearer to say how it is going, how AI is going to play a role inside 6G. But what is clear for now, or at least a bit clearer, is the role of AI in OpenRAN. And then when we are having the RIC, the XApps and RApps that are going to use different forms of machine learning, even some of the more modern ones nowadays. And these, as you also have heard, there were talks about intelligence at the edges and a more real-time usages of machine learning. So basically, there will be some interconnections, there will be some overlaps, but we need to see how 6G is going to be standardized, and what is going to be the role of OpenRAN in 6G.
Okay, thank you. So before we will conclude, I would like to ask each of you to just share one sentence for the end, what you would like to conclude this panel with. And then we can start with Lars, and then we'll follow up with the other one.
In short, we are building a system. That's one thing we need to remember. It needs to work as a system.
Okay, Navid.
Yeah, I wanted to say a definition of OpenRAN to share with everyone. And I want to Alex to confirm if it is correct. So my definition is OpenRAN is a collective action in building an open telecom network that complies with to 3GPP. So it's a collective action. That is what I want to emphasize, which means everyone needs to collectively work together from the test development. Still, it's very new. I mean, OpenRAN, ORAN concept was there, but it's really getting the momentum. It is new. A lot of things needs to be worked out. And that is why it's a collective action.
Okay, Alex, your confirmation and then
Yeah.
your word.
Yeah. Yeah, Navid, that's a great point. You know, at the Mobile World Congress, you know, all the major operators reconfirmed their commitment on the ORAN, OpenRAN. I mean, some operators they didn't announce any commercial deployment schedule yet, but there is no doubt that, you know, OpenRAN, ORAN will be the target or RAN pictures. So, which is a very encouraging. So, and once again, in ORAN is you see it as a collective actions and the collective of different building blocks. Each building block probably considered as a standalone features like open front haul, RIC, SMO, and all cloud. So it's up to the community, up to the ecosystem, you know, where to start. You know, you want to start from 1 or 2 or 3 all together, etc. So we need to share our experience, our knowledge, and innovation and insights. So with all together, then I think we can really realize and the dream or the vision of ORAN, OpenRAN. And thank you for, you know, this wonderful session today.
Thank you. Thank you. And I wanted to ask Ahmed, but he just disappeared. So Mel, could you like say some few words for the end?
Sorry, I have some internet issues, if you don't mind. Basically, my opinion is the one sentence that I want to wrap up here is that we have OpenRAN, and the OpenRAN enables, as far as I can see, that smaller players, XApps and RAP developers, to enter the market, and that's a very big thing.
Okay.
Thank you.
Mel?
Well, I think it's a challenging time, but at the same time, a very exciting time to boost innovations. Well, thank you.
Thanks. And over to you, Michele.
Yeah, I second what everybody said. It's an interesting time to be doing research on wireless, and there's new ICVs as new pathways to allow research groups to enter the actual market and to bring innovation in actual products.
Okay, thanks. Please do not drop for a second. Well, thank you, everybody. Thanks for all the speakers and to the audience.